In this video, I'll be looking at a binary search tree. Binary search tree is basically a way of organizing numbers or data in a ordered fashion using a tree. And it turns out it's a faster way to store things than just in a list. So if we look at this list of numbers here, with the 6 being first, the 6 just becomes the root. And the basic idea with a search tree is that a number will either be less than or greater than the node we're looking at. So if we look at the 3, so we start with a 6, that's the root. The 3 becomes the left child because the 3 was smaller than the 6. If we look at the 4 now, that's actually smaller than the 6, so it'll go to the left. And it's greater than the 3, so it'll go to the right. That's an empty spot, so we place the 4 there. Now let's look at the 2. Smaller than a 6, smaller than the 3. That's a leaf, so it goes to the left. Let's look at a larger one. So 8 is larger than 6. The right child is null on 6, so 8 becomes that child. 7 is greater than 6, less than 8. 5, less than 6, greater than 3, greater than 4. That's a child. 9 is greater than 6, greater than 8. And 1 is less than all of the rest of these, so it walks down the left branch. So that's adding things in. If we're searching, we do a similar pattern. So let's say we're looking for a 5 in the tree. So we look at the node, that's not a 5, and 5 is smaller than that, so we go to the left. 5 is larger than 3. 5 is larger than 4. And we finally find the node that matches. So yes, indeed, it is in this list. Now let's look at something like 10. 10 is greater than 6, greater than 8, greater than 9. We've reached a null child, and so we know it's not in the tree. Deletion. This one's a little trickier. There's two possible cases you got to worry about. The first is that if the node is in the tree, so there's 2 right here, if it only has one child, we just move its child up into its place, including any subtrees of that child. So if there were more nodes off of this 1, the 1 would move up along with all of its links. So we take the 2 out, and we move the 1 up into its place. Now if there's 2 children, so let's take a look at this tree. I moved the 4 and 5 to make this a more interesting example. But let's say we want to delete the 6. We pull the 6 out, and then we find the next largest or next smallest node that would go there. The way you do that is the next smallest one, you go left once and then right as far as you can. So in our case, going left once and right as far as we can will give us the 5. Alternately, you can use the next largest one, so that would be going right once and then left, left, left until you reach something that doesn't have a left. So in our case, I'm using this 5 here, so the 5 is going to go up here. So that goes up to the top. Now there's a hole in the tree still. So what we have to do is we have to move its subtree up to here. So the 4, along with any children of the 4 that are below it, basically move up 1 spot in the tree. And that repairs the tree. Because its parent was larger than the 3, we know that it's actually proper as far as being less than or greater than parents. So that takes care of that. All right, hopefully that gives you a chance to see how binary search trees work.